All right, so it's such a beautiful spring day here on campus. I'm going to record outside. Here, Stanford campus. It's just kind of sunny, park-like, filled with college students, just kind of like what you would have thought. So the topic for this section is, what is software? What is it? What is code? How is it that something runs on the computer? So when we talked about hardware in the computer, we talked about the CPU. That's the brains of the thing. So the CPU is what actually does running. And the CPU implements what is called machine code instructions. And machine code instructions are extremely simple. So one machine code instruction might add two numbers. Another instruction might compare two numbers to see which one is bigger. For code that we've seen, so something like pixel.setRed10, that's much more complicated than an individual machine code instruction. So the way it's going to work is that pixel.setRed10 will ultimately expand to a series of maybe 5 or 10 of these very simple machine code instructions, such that when those 10 instructions are run one after the other, it sort of has the effect of setting the red value of the pixel to 10. And I'll get into more detail later on about how that expansion happens. So I think a good first question for running in programs is like, all right, well, what is a program? So I'll look at the right-hand side of this diagram. So a program, and I'll sort of use as my running example Firefox. So a program is made actually of just an enormous sequence of these very simple machine code instructions. And so when Firefox is running on your computer, that means somewhere in RAM there's a block of these instructions such that running them does the things that Firefox does. So blinks the cursor, takes URL, draws, gets web pages, all that sort of stuff. So the individual instructions are really trivial, right? Just add two numbers. So how does it get from that to like blinking the cursor? And the best I can say is it's maybe sort of like the relationship between sand and sculpture. That each instruction is like a grain of sand. Like by itself, it's meaningless and it kind of looks like all the others. But if you put them together in just the right way, you can build this complicated overall structure. And so that is the way that Firefox is built out of these simple instructions. So the way it works is the CPU over here on the left runs what is called a fetch execute cycle. And all that means is that the CPU will start off, let's say here with instruction 1, and it'll load that instruction and run it. Or sometimes we'll say it executes that instruction. So it adds the two numbers, or does whatever the instruction says. And when it's done with instruction 1, then it just goes down the list. It goes to instruction 2, and it does that one. It goes to instruction 3, and it does that one. And so on. It just runs through the sequence. So when we say that a CPU operates at 2 gigahertz, 2 billion operations per second, it's these little instructions that refers to. So there's obviously a big variety of instructions, but I'm just going to point out a couple special types. So one type of instruction has the effect of changing the order that the instruction. Normally the CPU just runs down the list, does them in order. But let's say instruction 4 maybe says, oh, jump back and start executing again at instruction 1. And so think about what the CPU is going to do. So it's going to do instructions 1, 2, 3, 4, and then when it gets to 4, it'll sort of jump back and do instructions 1, 2, 3 again, and then 1, 2, 3 again, and again. And you can sort of see that's how loops are implemented. Just arranging the instructions so that there's some piece of code we want to do 500,000 times. Well, you can set up an instruction to just loop back and so do those instructions again and again. Another sort of instruction, a related idea, is an instruction, let's say instruction 2 here, which tests some condition. And if the condition is true, maybe it skips ahead to where instruction 5 would be here. So that's how if statements are implemented. You have an instruction that's going to look at some condition, and if the condition is true, it's going to sort of tell the CPU to go over here, and if it's false, it'll go over to some other place. So by arranging these instructions just so, you can get the effect of something that in our code looks like an if statement. Alrighty. So, so how does a program get running? How do we get to this state? So I want to imagine you've got Firefox on your flash drive, the file. So on your flash drive or on your hard drive. So here I've stored long-term, persistent storage down here, and here's RAM, and here's the CPU. So when you've got Firefox on your hard drive, it's a file basically, and here it's called Firefox.exe. That's just a Windows convention for how to name a file, which is a program, but it helps keep things clear here, so I'll follow that. So Firefox.exe, that file, it has a lot of bytes in it, and for the most part, those bytes are just the instructions that make up that program, plus some icons in them. pictures and other stuff. So what I want to think about is, well, what happens when you double-click Firefox.exe? How does it start running? And basically what happens is there's two steps. The first thing that happens is the bytes for these instructions, at least enough of the instructions to get started, get copied up to RAM. So it just puts the instructions in RAM where the CPU can get at them. And then step 2, just tell the CPU, okay, well, here's instruction 1, start executing here. And so then the CPU just starts ripping down this series of instructions, and now it's running Firefox. So I think this leads to the question of like, well, who did this, right? Who handles the double click? Who gets Firefox running? And so that's what an operating system is. So the operating system is a set of kind of supervisory and administrative programs that sort of, organize the whole system. So in particular, the operating system manages multiple programs and starting and ending programs. So a modern computer can run multiple programs at the same time. And so the operating system sort of keeps things organized. So it does the initial startup of a program, giving it some RAM to use and maybe giving it a window to draw in. Also, operating systems try to keep programs isolated from each other. So each program has its RAM that it uses, but it can't necessarily just go mess with the RAM of some other program. So that helps if a program has bugs. Hopefully it'll just mess up that program, but not mess up some other program that you're running. Or maliciously, if a program is trying to do something bad to some other program, the operating system tries to keep them separate. So the operating system is really the first thing that runs when your computer starts up. So that's what's going to put up those first windows and maybe show you what's on the hard drive. And then from thereafter, you can double click or do other things, and the operating system will start those programs for you. So that's really the thing you're seeing when you start up your laptop. Digital camera, you don't think of it as a computer necessarily, but it's really the same. When the digital camera first starts up, there's probably a couple programs. There's maybe the program that takes pictures and the program that lets you look through the pictures you've already taken. And so when the camera first starts up, there's a little bit of administrative sort of get the programs running to sort of show you the interface, and then it just lets you go from there. So just as a last thing, there's sort of this terminology, boot and reboot, I always thought was kind of funny. Like, where does that come from? And it refers to the sort of chicken and egg problem of like, well, when the computer first turns on, when it first starts up, how does it get itself organized? How does it start running a program? And this terminology actually comes from sort of an old joke about if you wanted to get over a fence, well, what you could do is just reach down to your bootstraps and pull up and just like lift yourself over the fence that way. And it's obviously kind of absurd. But it has the same quality of like, well, wait, what program does the computer run to enable the computer to run programs? So it's sort of a chicken and egg problem. So the way it works is that the hardware, the CPU, has when it recognizes that it was turned off and that it is just started up, and so there's a special tiny program that is hardwired into the computer to run at that moment, and that program can maybe check what's hardware is there, do some like basic early startup stuff, and then pretty much it looks around for a hard disk or a flash drive or something that contains an operating system on it, and then it can start that operating system, and then the computer can start up in that way. So that's why it's called boot up. It refers to this old bootstrap idea, and then that's what rebooting is. So reboot means just to sort of, we want to get a clean slate, so it's going to shut down and then start up fresh. All right, so now you know.